So let me just go over this a little bit. I think I may have done it last time, but just to be sure. But the way that multiplication and division works is your sign is determined by the signs of the things you're multiplying and dividing. If you've got two signs that are the same, in other words, if you've got two positives, which will be one example here, number 2, then your product or your quotient is also a positive. All right. Most people kind of know if you have a positive 10 and a positive 3, 3 times 10 is 30. That's just the way that, you work with regular whole numbers. You don't think about the negatives, but the negatives work very similarly. When you've got two that are exactly the same, so a negative 11 times a negative 8, then we would have a positive 8, the 8. If they're mismatched in any way, in other words, an odd number of negative signs is another way to look at it. For example, here we got a positive 9 times a negative 6. So 9 times 6 is 54, and the sign is determined by the odd number of negative signs, which is one negative sign. One positive, one negative sign. So negative 54. And this one shows what I was saying when I said an odd number of negative signs. It doesn't necessarily have to be one. If you're multiplying a bunch of numbers and you've got 5 numbers and 3 of them are negative, then you're going to end up with a negative outcome. Here we got 3 numbers and they're all negative. So watch what happens if we take it step by step. Negative 3 times negative 2 is positive 6. And positive 6 times negative 5. See that? Now we've got used up 2 of the ones here using this principle. Same sign, positive 6. And then positive 6 times negative 5 is negative 30. All right. So again, for division, same rules play out. Negative 30 divided by 3 positive is negative 10. Mismatched signs. Negative 20 divided by negative 4 is 5. The 2 negative signs means it's positive. And it doesn't matter where the negative sign is when you're talking about division, just like it doesn't really matter by multiplication. The first sign could be negative and the second sign positive. The first sign positive, the second sign negative. You're still going to get a negative because you only got one negative sign. So here, the difference between 6 and 4 is the negative signs now in the denominator, but that doesn't matter. You still just perform the math, 12 divided by 10. And this is one of those ones that all it does is just simplify down. It doesn't, you can't really write it as a whole number. So you just divide both numerator and denominator by 2 and then give common sign. Now, why they move the negative sign up here, it's kind of strange. It really doesn't matter where the negative sign is. It could be in either the numerator or the denominator, or it could be out front. Those all three mean the same thing. All right, so start working on these. I want y'all to work a few of these and tell me when you get an answer. If you want to shout out an answer, you can. I'm going to try to I was trying to put a poll in here to. Oops. What happened? So it doesn't like it that I'm logged in from a different computer. Let me tell you. Because I want to just try the polling thing. I like to have another computer open so I can see what you folks are saying. It still doesn't like it. Well, I don't get it. I'll fiddle with the polls later. All right, has anybody else come into class? Kenneth Walker, I see. Let's see who else is here. I think I got everybody that's here. All right. So let me just ask you about number one. What's the sign going to be of number one? Two negative signs. So it's going to be what?
Positive.
Great. So 2 times 10 is 20. So it'd be positive 20. On number 16, what's the sign going to be? One negative sign. So what's the sign?
Negative.
Good, good. Now, the numbers still play out the same way. So 4 times 16 is 64. So it's negative 64. Again, the difference between 2 and 3, it's not a whole lot of difference. It's just the placement of the negative sign. So you just count. How many negative signs do you have? You only have one. So we got a negative 30. All right. How about number 4? What is that difference between 4 and 5 as opposed to the other 3?
Negative.
This is division, first of all, okay? Most of the way that you'll see division in this course, always during the first week, they always throw in, and there's one down here at the bottom. It kind of ticks me off. They always throw in one that's got a division sign in it. Division signs are not useful in most levels of mathematics because it looks too much like an addition sign. So the fraction bar is the way that most math courses denote division. So 4 is negative 15 divided by 5. So first of all, what's the sign going to be? Same rule.
Negative.
Negative. Good, good. Now 15 divided by 5 is 3. So we got negative 3 on that one. On number 5, what's the sign?
Positive.
Positive. And 20 divided by 10 is 2. So positive 2. Now, 6 and 7, I want to make a little explanation. There's not really anything to show for either of those. So I want to show you something. I'm just going to write something out on the board here. I've already got it written out for my Thursday class. Because they're one day ahead of you, I think. I tell you what, it must be back here. All right, here we are. All right, so here's what we're looking at. 0 divided by anything but 0 equals 0. All right, in other words, if you've got a numerator in the 0, the 0, doesn't matter what the denominator is as long as it's not 0. Now, I was going to show you. Using a calculator. See if you do 0 divided by 9, you're going to get 0. 0 divided by 789. Oops, what happened? 0. Let's see if we can make it negative. So it's going to be divided by negative. So what is it? Negative 0? No, there's only one 0, and that's just 0. Okay? Doesn't matter how big, how large. That's like something in the trillions there. It's still just 0. Okay? And a calculator is one of the best ways to illustrate that. Because why does it happen? Well, the reason why it happens, if you have 0 of anything, then you can't, what you're doing when you're dividing it up, you're saying the denominator is what we're dividing it up to. Well, if you have 0, then you got 0 divided up. Doesn't matter how many pieces of, if you have 0 pieces of pie and you try to cut it up into a million pieces, well, you still got 0 pieces of pie. That's all there is to it. You can't not divide up 0 and get anything more than 0. Now, here's the other thing. The other thing was any number except 0 divided by 0 is undefined. Now, undefined is a way of saying that we don't have any kind of way to reconcile the idea of a number divided by 0 in mathematics. Seems kind of simple, but that's really what it amounts to. So as long as 0 is in the denominator, then we've got an undefined expression. All right, let's look at that calculator again. Now, it's got to be something up there. If it's 0 over 0, that means something special. Not anything in this class you'll ever have to worry about. But it does have one of those kind of strange meanings. But let's put 7 there and divide by 0. And they're going to tell us error division by 0, because as far as the calculator is concerned, it doesn't have a rule to help it do that. So they say division by 0. The preferred way of putting it in this class is undefined. Undefined. So let's go back over to that sheet. So 0 divided by negative 12 is 0. Negative 12 divided by 0 is what?
0.
Undefined. Undefined. Don't say 0. It's undefined. Here's 0. This is undefined. And probably the one reason why that's a hard thing to remember is because of the fact that there's really nothing to do to show you. I mean, it's really difficult to get idea to get across. All right, so why don't y'all try to work these two out and tell me what you get. I'll be right back. All right, anybody come up with an answer on that yet?
Negative 60 for number 8.
The third one? I'm sorry, eighth one?
Yeah, negative 60.
Yeah, and let me do it on the board. See if I can copy it and paste this over there for people that might have questions. All right. I may even have it over here already. No, I got certain ones, but not those two. Oh yeah, here they are. So you got to do, when you multiply in order of, you got to do 2 at a time. There's no other way around that. So it doesn't matter which 2 you do in multiplication. So negative 5 times negative 10. I'm sorry, negative 2 is positive 10. Positive 10 times negative 6 is negative 60. Okay. So there's 3 negative signs. So we know immediately it's going to be negative, because 2 are going to turn into a positive, and then you'll have 1 negative left. All right. Now, did anybody kind of take a little bit of the surprise away? I should have said do 9. What happens on number 9?
It comes out to be 0.
All right, good, good. And the reason being is you can do those first operations. 8 times negative 2 is negative 16. Negative 16 times negative 3 is positive 48. And then positive 48 times 0 is 0, because 0 times anything is 0. All right. Okay. So why don't you see if you can do 10? And remember, the best way to handle this, I think, is to just do the numerator first, and then do the denominator, and then do 1 division. So try 6 times negative 8, and then that's your numerator, and then your denominator is negative 2 times negative 12. And somebody tell me if you get an answer on that. Let's see, did anybody else come in here? I keep hearing like the doorbell, but I got most everybody that I see. About 10 o'clock, I'm going to call the other people that I don't see if they're hiding out there. All right, anybody come up with anything on number 10?
Negative 2.
Negative 2. What about number 11? Handle the multiplication. Now, we're going to talk about this, but whenever you got multiplication and addition and subtraction mixed, handle the multiplication first, and then do the subtraction 16. So that's negative 14, take away 16 negative. So that's negative 30. And then you go into negative 3, 1 plus 3 is 2. So that's going to be negative 15, I believe. Let's look at it. All right. So this is where I was drawing that idea from about to do multiplication first. Most people know about this because we're going to look at operations, orders of operations next. We kind of do a little bit here, but I wanted to save that one. So this is the one we were just talking about, the negative 2. Y'all got that one? And then this one, as I said, it's 2 times negative 7 is negative 14. Take away 16. So these both are the same sign, so we add them, negative 30. Down here, it's negative 1 plus 3, so we take the difference, and it's a positive. So it's negative 15. All right, come back to that last one. Now let me go over the order of operations things, and then I'll leave you on that. They start talking about it before we mention it. But generally speaking, if you got any parentheses, then that's the place you want to head first. And then you simply drop back down and start going through the order after you get inside the parentheses. But the next thing you do is exponents. So anything where you got something raised to a power. And then here's the thing you got to watch out for. Multiplication and division are not separate because they're inverse operations. So we just got to remember to do them left to right as they occur. If you don't do that, like if you just come and do all the multiplications first and then come back and do divisions, if they're both mixed in there, then sometimes it's not going to work out right. So that's why you just treat them the same and do left to right as they occur. So just remember that. There might be one problem, in this chapter that makes a difference on, and I'll bet you there's going to be one in there. All right. And then addition and subtraction. With those, it doesn't matter. You could do all addition and do all the subtraction. All right. So try and handle that, and realize down here that that little thing I've got highlighted is a division sign. So head inside of your parentheses. Now there's a difference between parentheses like this and this one. This one right here actually has something to do. It says 3 minus 10. So what you got to do is you got to put in a -7 there, and then divide that into 7. 7 divided by -7. Now, this parentheses right here is there, but there's nothing really to do in there. It's really just hide the negative sign, because parentheses also means multiplication. When you got it butt up against a number like that or up against another parentheses, it means multiply. So if you didn't put that in there, then you would have -7 minus 3, which is something together altogether different. But it's saying -7 times -3. All right, so give that a try, and let me know if anybody gets anything, and then we'll go over and look at it step by step. Hold on a second. Students trying to find their way into class. All right, sorry about that. I was just looking at the roster, and it was an email from a student that's not been in class before. Okay. All right. So did anybody come up with an answer for that one, number 12?
-17.
What was it?
-3 is what I got.
All right. Look at that. Don't get the hard ones. All right. So let me just show you how to handle it. as I had said, if you got some parentheses, that's the place you want to start first. We got, oh, this is the second step, because the first thing it said it was 3 minus 10, so that's -7. So +3, -10 means -7. 7 divided by -7 is -1. Now, once you got that, then you can kind of back up and then handle there's no exponents, so we're just going to handle the multiplication. So -7 times -3 is +21. One negative sign means it's -12 there for the 4 times 3. And at the bottom, 3 times -1, 21 minus 12 is 9. 9 divided by -3. Oops. Yep, -3. I'm sorry. Yep, we got it. Something popped in my head, making me think that I've written something down wrong. Any questions about that? All right. Let's see here. I'm going to just see if anybody's lurking out there. If I don't call your name, it means I already got you. Victoria Aldrat. Yeah, out there. Joni Davis. Lurking out there. Rowan Issa. Outside, out there. Oh. Nari Morris. All right, and Karen is the one that was outside trying to get in. Hector Rivera. Well, this is the one class where I got like almost half of the class missing. I don't know if it's because people sign up for an early class and they don't like it. Jade Williams and Tynesha Williams. Okay, and as I said, I got everybody else.
Yeah, my name
Did
is Nisha Williams.
Well, you're in here, right?
Yeah.
Okay, as I said, is I can tell who's in here, but sometimes I'm afraid I miss somebody. So that's why I was calling the people that I had not seen.
Okay.
Okay. Oh, wait a minute. I did call you. Yeah. Okay. I see you now. Tynesha. I'm sorry. Because I got 2 people last name Williams, but I had not seen yours. All right. So we should be all right. So like I said, actually we got 3 Williams. So there was a Jade Williams I never did see. Hector Rivera I didn't see. Niari Morris I didn't see. Rowan East I didn't see. Joni Davis I didn't see. And Victoria Aldrat. All right. And keep in mind, I'm working on the getting where the grades are going to appear right. I know that it looks like there's assignments over there, especially if you're on your phone and try to get into Canvas. So that's going to take me a while to do that. I got one of the classes done over the weekend, and then I'm going to start importing that. I just want to make sure it works right before I do it. But everything, remember, is in the My Math Lab that you're ever going to work at. But when it's done, it gets what they call synced or pulled over to the Canvas gradebook. All right, so let's look at 1.7, and then we'll back up to 1.4. All right, which is where we handle the, no, it's not 1.7. The 1.7 is what we're just looking at. It's 1. Wait a minute. Oh, here it is. It's 1.3. I just wanted to point this out. We did look at the at these kind of things initially, but I just wanted to point this out. When I showed you how to use a factoring tree, like you can use it for both greatest common factors and for greatest common denominator, lowest common denominator, and greatest common factor. You can use the factoring method to do that, and I find that that's the most efficient way because it breaks down the components into the prime factors, and then you can just pull them out one by one, and then what you got left over is what you got. But you can also kind of do things by division, and this is what I may have told you, that if I'm have got a fraction and I look at it and I don't see any obvious greatest common factor, then I might just look and say, oh, they're both divisible by 2, because if they're both divisible by 2, they'll end in an even number. And so if I do that, I'll say, well, okay, it's divisible by 2, so I divide by 2. Then I'll look at it again. If it's still divisible by 2, then I'll divide by 2 again. And it may take me several steps, but generally speaking, you can get through like that. But there's also other possibilities, and this is why when you're using this division method, you got to find the largest one possible, because just because it's not divisible by 2 any longer doesn't mean that it's not divisible by something, because there's also 5, and you can tell this one's divisible by 5 because the numerator ends in 5 and the denominator ends in 0. All right. But there's also another one that I know, and I can just tell you this, that if, let's look down here. For example, both 4 and 5 are divisible by 3. And the way I can tell is if you add up the two numbers in the numerator, 5 plus 1 is 6, and 6 divisible by 3. 15 is also divisible by 3, 5 times. 5 plus 4 is 9. 9 is divisible by 3. So we can divide that down to 3. I mean, we can divide 3 into 45 and get 15. Same thing here. 8 plus 1 is 9. So 9 is divisible by 3. That means 18 is divisible by 3. 3 times 6 is 18. 3 plus 0, divisible by 3, because that's 3. So 3 goes into 30 10 times. So those are the 3 primary ones that I use. I know there's a few other ones, but I don't really know them. So it's not like you have to always be able to judge your greatest common factor. All right. You can just kind of, do it piecemeal if need be. All right. Why don't y'all look at those and tell me what's going to happen with number 1. What is going to be the greatest? What's that going to simplify down to? Notice that both 4 and 10 are even, so they'll divide by 2.
2 over 5.
Yeah, and then you get to 2 over 5. And one thing you kind of know about 2 over 5 is once you've got it broken down into prime factors, because you can't break down 2 anymore or 5 anymore. So unless, when you have that kind of scenario, then you can't go anymore. So this is 2/5, because you can divide by both 4 and get 2, 5 and get 2, 2/5. How about number 2?
1 over 3.
Yeah, you see 5 is obviously divisible by 5, and so is 15 is divisible by 5. 15 divisible by 5 is 3 for the denominator. 5 divided by 5 is 1. 1 over 3. Good. What about this one?
3 over
3,
4.
4.
Yeah, 3/4, because 6 and 8 are both even, both divisible by 2. So 2 goes into 6 3 times, and 2 goes into 8 4 times. So we've got 3/4. Now, both of these are end in 5, so it's definitely divisible by 5. But since these are smaller numbers and I recognize that 15 divides into 45 evenly, we got another one there that's a 1/3, right? 15 goes into 45 3 times. 15 goes into 15 once. So again, another 1/3 there. Let's see a second. All right, so what about I'm not sure I showed y'all this, but if you're taking the difference between 20, in other words, if we're at 20 degrees and we're somewhere where it's cold enough to drop down to -10, what is the total drop
30.
in temperature? Well, and the reason why I wanted to use this is because when we're subtracting a number and then a negative number, in other words, we're finding the difference from here to here, that's what they call the difference, then this is why that turns to a positive. When we're subtracting a negative, it ends up being a positive 10. So 20 plus 10 is 30. So I drove this out for my class, but I'm not sure I'd showed it to you folks because this is just a visual example of why that happens. Well, let's go back. To these. So what does 18 over 30 simplify to? And this is the one I said, these are both divisible by 3, but they're also divisible by 6, I can see now, but you can do it in 2 hops if you want to. Like, for example, 18 over 30 so let's just say, oops, it was 30. Yeah. Let's just say, well, they're obviously divided by, both divisible by 3. And what happens? Well, I get 6 over 10. Now, the problem is there was a larger factor, and the larger factor was 6, but you're not out of, you're not, you don't have to back up. Now you can just divide both by 2. In other words, it's really hard to break something in math as long as what you did was correct. In other words, it followed a basic rule. So 6 divided by 2 is 3. 2 into 10 is 5. All right. So sometimes if you don't get the largest one, you just still got to check, though. Make sure that it's totally simplified. How about number 6? (24) divided by 36.
2, 3.
This is one of those, if you don't know your multiplication tables of things above 9 like me, I mean, I know a little bit about the 12s, but both 24 and 36 are divisible by 12, and that's the biggest one. Like I said, you could do it by halves first, but if you do it by that, then you're going to have 12 over 18, and then you have to do it again, and then you would have to do it again with a 3, because there's the prime factors are 2, 2, and 3, which is 12, because 2 times 2 is 4, 4 times 3 is 12. So 12 into 24 goes twice, and into 36 3 times. All right, what about number 7? What can we do with that one?
Nothing.
Any common factors come to the top of your head?
No.
No.
Yeah, and you can look, they're not even, so you can't divide by 2. And like I said, is the ones that I know are 5s. 5 doesn't divide into those. And also, 2, if you do add up the ones like I told you, 1 plus 6 is 7. 7's not divisible by 3. 2 plus 5 is 7, not divisible by 3. So this right here is already simplified, okay? All right, what about 8? There's probably a couple of different ways to do it. There's a hard way and an easy way. What would that be?
2/3.
6 and 10, 15. We got to keep your 6. Now, it just kind of depends. Like if your homework said write it, the answer is a mixed number, then you could just simplify this part. But if it said improper fraction, you'd have to put together. But let's see. So both of these are divisible by 5, right? 5 into 10 goes 2. And then 5 into 15 goes 3 times. So that's a mixed number. If you do the improper fraction, just kind of refresh your memory, 3 times 6 is 18, plus 2 is 20 over a third. So if you need an improper fraction, you got to go that step. And the reason why I did that is, first of all, you got to always check what your answer is supposed to be in. They'll always tell you. But the problem that I wanted to differentiate here is, generally in math, like where we're at now and above, you're going to be better off if you write in improper fraction form. It's just going to be a lot easier to do operations like that. Now, what I mean by operations are these kind of things here we're going to look at, the order of operations. All right. All right. So as I had said, is generally speaking, this is the way you handle things. You just got to remember about the multiplication division. Sometimes it's not going to matter. But this is the one thing that I would just like to bring your attention about multiplication division. Left to right as they occur. All right, they're not separate operations. And that's the only drawback of using this. So as long as you're just using it as a memory tool, no big deal. Just correct it for that instance, okay? All right, so let's go back over there and look. Hold on a second. All right, before we go on to this 1.4, let me just I know we got a new student in here, but I just wanted to ask, is there anybody in here that hasn't figured out how to get to those course materials again? If you haven't, I want you to pay attention because I'm going to show this again, all right? And I know that there's people out there. I mean, this is our second day of class, so don't feel bad if you don't know, because in all my classes that always happens. There's somebody hasn't figured it out, okay? So pay attention now. Hold on a second. All right. So, all right. So, as far as that course materials is concerned, when you come into the course, remember your two most important documents are here: the syllabus addendum and the course calendar. The course calendar is probably the most important document because um, it just shows you where we at any given day. And remember, we're here quite a bit. We're here 4.5 hours a week. All right. This is a 5-hour class. So this is the course calendar. When you hit that and bring it up, so we're right in here. Okay. So this is the course calendar. Over here are the things that you're assigned for homework in my math lab. Now, there's some due dates over there. I didn't set them up and I didn't realize that they were kind of all towards the end of the active testing session. In other words, the first test will be that Monday, February 8th. I'm going to try to give you an extra day or two there to give you to work on that. But anyway, I think the due date says something like 7th or something for all of these. Now, this is why I put this in here. I recommend completing my math assignments within 2 days of covering in class. If you do that, you're not going to get overloaded down here, all right? So for example, on this one right here, January 22nd is what I would say. You'll still be able to get in there and do it, but I'm just saying is that's what I'm recommending. 24th here. I'm sorry, 26th, which is 29th, February 3rd, February 5th, and so forth. Because that test is going to be on that date right there. Like I said, I'm going to probably give you through the 9th, like 7th, 8th, and 9th to work on it. But if you've not done all this right here and you're trying to do that and get ready for the test, then you're going to be setting yourself up for a lot of work to do. So remember, there's other little things in there too. There's usually like a quiz or practice test or something like that. All right. So the syllabus addendum, I'll let that, I'm not going to go through that again because that just tells how I got the setup course setup for points, the rules and all that for the course. But here's what I was saying is to get into the My Math Lab the first time, you go through course materials. And then you're going to hit launch courseware. On the student version, they have a little thing up here that says opt out. I advise you not to press that because then you're going to be getting the materials on your own. This takes all that out by clicking on launch courseware. The first time you do it, when you click on this open My Lab and Mastering, if for a student, it's going to ask you to register. All right, because if you've already got an account, go into that account. In other words, if you're repeating this class. Now, in the announcements, if you want a visual for it, in the announcements, for the announcement that I sent out, I've also got it linked in the syllabus addendum, but I've got it here actually attached, a PDF, the way it looks like for the student to go through that process. I can't show you that because I don't have a student account. But like I said, once you get that open, then once you get that account established, then when you click on launch courseware in the future, when you click on launch courseware in the future, and then you click on this, it'll go right into your My Math Lab account. And as I said, is most everything you got to worry about is in assignments. I don't trust that calendar over here on home where it first comes in at. I don't understand how it works because they don't have anything to click on it. Like for that exempt one. See that? So, plus, I don't know. Sometimes I've come in here and I don't see every one of them. So I would just recommend going into assignments. If you're in assignments, then just start at the top here and work your way down. If you miss any due dates and you can't get into it, then just start where you can and keep going. And just notice here that I've got that in here about that proctor review check. At some point, you got to test that out because specifically for the midterm, you got to make sure you got the technical capabilities to run the proctor U review. It's actually called proctor U record now. But anyway, that's what that's for. And then we'll have a trial run of that. See, and these are all the ones we haven't got down here yet. We're getting ready to get down here. And then before we have our first test, we're going to go through chapter 2, or most all of chapter 2. We're going to save 2.8 for later. And then there's a quiz and there's a practice test and a test. Especially this practice test, I recommend using that to find out what it is you don't know. Because usually when you're doing the homework has those helps. So when you got helps, you can go up and click on something if you get stuck. With a quiz or practice test, those work because these are both actually quizzes. They're just named practice test, and this one is called a quiz. But these are quizzes, and usually you can take them more than like 5 times or something. But they work just like a quiz and test, or like a test, in that you're not going to have any helps. So you got to go through it without any help. And so, of course, when you do this, you're going to have one chance, one attempt, and it's going to work like the tests are. Generally speaking, for most people, if you take that practice test and you take it once or twice and you get an 80 on there, you could more or less expect to do about that same on your test. All right. If you get a 90 on there and you're happy, you can move on. I wouldn't advise doing anything less than an 80 or 90. But remember, I think you got 5 attempts on these, so you could max it out just like you can with your homework. You can almost have 100 on all of these things up here. All right, I think that's pretty much the gist of it. Anybody got any questions about that? All right. So if you got any more questions, we'll probably end class a little bit early today. So if you got questions, you can stick around. All right. What we're going to do, I think, let's take a little short break, and then we'll come back and finish out our last hour and 10 minutes or whatever it is, because it's really kind of hard to concentrate. And then we're going to start on what was this thing at? Here. That's what we're going to be looking at. All right, the order of operations stuff. All right. And if you got questions, like I said, I'll wait here for a few minutes, but I'm going to take a little break in a minute, and then I'll come back. And we'll start up in about 5 or 10 minutes, okay? I'm going to pause the recording. All right, so we got everybody back. I just wanted to see if these other people had showed up, the ones that I didn't get. Victoria Aldrett, Joni Davis, Rawan Issa, Niari Morris, Hector Rivera or Jade Williams. Did any of those folks show up? Okay. All right. So remember what I had showed you about this memory tool that a lot of people have dealt with, PEMDAS. Please excuse my dear Aunt Sally, is what I've heard it as. I know there's probably different ways to say it. And it's just a way to help you memorize the order. But the one little thing that I wanted to mention, and that it makes a difference, is that multiplication and division are not handled separately. Multiplication does not have precedence over division. You have to realize that it's multiplication and division as they occur left to right. All right. If you handle that, you shouldn't run into any problems. If you separate them up, there's a chance on some problems that you're going to run into issues. Addition and subtraction doesn't have the same issue, but anyway, let's go over here. All right. So we're using order of operations. So what it just generally means is we're going to have everything in here, including exponents. The first one that they start out with, the example, is 15 minus 12 divided by 6 times 2 plus 5. And like I said, it's really pretty bad form, but they seem to always do it in the first chapter of all of these textbooks. And I know that people have probably been dealing with it like that for years in, high school and junior high, especially we use the division side. Generally, you're going to see that go away. And that's why we have fraction bars, because fraction bars mean division. But anyway, so what we got to do is we got to go left to right on a division and then a multiplication. So negative 12 divided by 6 positive is negative 2. And then we do the multiplication, because remember, the highest one we had was multiplication and division. So we did those first. So then we're going to handle that last one, negative 4 there. And then once we got just negative, adding and subtracting, it doesn't really matter the order. But anyway, it's 5 take away 4, 15 take away 4, which is 11. 11 plus 5 is 16. All right. Let me bring these. Over to the blackboard. All right. So let's just try to handle each one of these. What happens on this first one here? What do we do first?
Multiply 7 times 9.
Good enough. And that's 63, right?
Yeah.
Now we come back and do the addition. So we got 71. All positive, so none of that funny sign stuff we got to worry about here. Questions about that one? All right, now remember, it's PEMDAS, so parentheses is the first thing. So what we got to do first is handle that. 17 take away 2, which is what?
16.
All right, so 35. That's a crazy looking 15, but it is. 35 minus, and what kind of 15 is? It's a positive one. You don't need the parentheses if it's positive, but I'm already wrote it. And then that's a division by, right? All right, so what comes next now that we had that? Took care of our print.
Divide.
Yeah, divide. All right, so it's 15 divided by 5. Only one negative sign, so
3.
3. Good. So remember, we got to bring that sign down there. If there had been a negative sign on this one, we would put a positive there, but the signs are mixed, negative and positive. All right. So on this one here, what can we do first?
Multiply 9, 2.
Yeah, left to right. There's a multiplication and then a division. So let's do -9 times 2. So that means the sign is going to be negative because it's a -9 times a positive 2. So that's going to be 18 negative. Now, here's the next multiplication division. So it's 6 divided by 3. And that's a plus right there, isn't it?
18.
6 divided by 3. It's divided, not multiplied. Right? 3 into 6 goes twice, correct?
Don't eat that food.
Hold on a second. What's that? I was afraid my mic wasn't on, but. So can you hear me? What was the question about this?
No.
All right, and then we just do the addition and subtraction. So 24 minus 18 is 6. And then plus 2,
2. Equal 8.
8. So these two were opposite signs. So we took the difference between 24 and 18, which is 6, and the larger number absolute value wise is positive. So it's positive 6 plus 2 is equal to 8. All right, any questions about those? All right. All right, so let's go on down here to number 4. What happens first? What do we need to take care of first? P as in parentheses. So we have to handle that first. So that's 2 plus 7, right? Which is 9. And then that's a divided by thing. I really hate those. I wish they wouldn't put those in there. All right. Now what? Now all we got is multiplication and division, and then there's a subtraction, but we do the multiplication first, right?
Yeah.
So 12 times 9 is, what is that?
108.
Good. All right, so now we handle the division. Okay, because multiplication division have to be done first before we do any addition and subtraction. So this is 24 divided by 12.
Twice.
And so it goes in there twice. And what's the sign? Negative and positive means
Negative.
it's negative. And then one subtraction,
106.
right? Any problems with that? All right. So now we're going to get in number 5 and 6, some exponents. It's going to be hard to squeeze things in here. Let's see. I'll just come straight down with this one, and this one's got plenty of room over there. Okay. So first thing is we got to do what's in here and what's in there. Well, actually, inside of here's got the parentheses. Inside the parentheses, you got some exponents. So we definitely want to do that first. All right. So what does 8 to the second power mean?
8 times itself twice.
Yeah, so 8 times 8 is 64, right?
Yeah.
And then this is 2 to the 5th power, which that means 2 times 2 times 2 times 2 times 2. Take my word for it, it's 32.
Yeah, you're right.
I've done it plenty of times because in Math 120, which kind of the next course after this for a lot of students, we do that a lot for a specific reason. All right. All right, so we still got some parentheses, but now we've got just got subtraction here. So 64 minus 32 is 32. And 24 divided by 6, I think, is 4, right? And then we can just go ahead and do this one. Won't hurt us to do that one. Now we're into the exponents. 3 squared is 9. And then we're going back to, remember, we're starting to, once we get one in, then we come back up here as high as we need to go and then go back down. So now we're essentially right here now, multiplication, division, addition, and subtraction. There's no multiplication, but there's a division. 32 divided by 4 is 8, correct? Eight plus 9 is 17. Any questions? All right, y'all all right on that one? Make sense? Why don't y'all try to do this one? I'll give you a few minutes, just a couple of minutes to work on it. See if you can get through it. And if you get an answer, tell me, but we're going to go through it. I just want to task y'all with doing something there. I got to figure out why this polling is not working. I really wanted to use that. See if it's working now. Oh, it might actually work. Oh, no. Strange. Oh, it's popping up into.
Lady.
All right. Anybody come up with anything?
I got 6.
All right. Well, let's see. Can anybody attest to that? Well, let's just go ahead and see. So the parentheses got to be done first. So 16 minus 5 is 11, right?
Mhm.
And then we'll go down here and we'll do the exponents. 4 squared is 16 minus 7. All right, so the only thing left is multiplication and then addition, subtraction. So 55 minus 1. And then this is 9. 16 minus 7 is 9. So then this is 54. And what did you say? Somebody, I heard, I can't remember who it was, but I think they said 6, right?
6.
6.
Yes.
All right. Good. All right, any questions?
No.
I'll tell you what, give me a second here. I want to try to, now it looks like this thing is actually let me go a little bit further. I wanted to use these polling and I'm trying to, but it's asking me to log in again here. Hold on. I don't know why. That's making me open up a different browser. All right. I thought I could. I don't know why it's wanting to open up a different browser. I guess because I was trying to open up that Microsoft Edge, which I don't ever use. All right. See if this fixes the issue. All right. Did anybody have any questions? Because I noticed that little note in the chat about where we started. I don't think we skipped anything, but if you think we did, feel free to ask. Okay. Because I don't mind going back. We got plenty of time. All right. All right. Looks like it's going to work this time. Okay. Well, I'll use it on something else, but I just wanted to make sure it was working. I just need to change the default browser. All right. Anybody got any questions about anything that we looked at so far?
No.
Just remember, what happened to the calendar? I have to go back and get it. So just remember, this is the one thing you want to carry with you at all times or be able to refer to. All right. So we're like right in here. All right. Let's see. What else did we not look at on that sheet? Well, there's another section. Well, not another section. It's all 1.4, but it's another subsection. Now, The first thing that we want to look at says evaluate the expression given that x is equal to 6 and y is equal to 2. This is where we kind of make it a little bit algebraic because remember, we've not looked at a whole lot of variables so far, but we refresh our memory about them and how they work. A variable is just a placeholder, and so we can let it be changed out for any value given that information, and we're given that information. X is equal to 6, y is equal to 2. So if we take 3x minus 2y squared and fill in x is equal to 6, well, it looks like this, because when you have 3x, that just means 3 times x. Okay? So 3 times 6 minus 2 times 2 squared. Remember, y is 2. Now, what's being squared is the 2. So we got to handle that first since this is an exponent. 2 squared is 4. Now we can just come back over here and go left to right. 3 times 6 is 18. And 2 times 4 is 8. And there was one negative sign. So 18 minus 8 is 10. Any questions? All right, so you folks do these, and then I'm going to come back 7 through 9, and then we'll work them out. If you get an answer on, just yelp it out if you want to. Let me see. While y'all working on it. And just keep an eye out that they give you 5 different variables, but they may not use all of them in the same one. All right, see if y'all can. Y'all see a way to. Oh, here it is. Yeah. Are y'all able to see that poll thing come up? Type in what you think is the right answer on that. right, I got a couple of answers that look good. All right, let me put in the, see if I can put in another one. I think I might be able to put in more than one at a time. Hold on. All right. So you can go on to the second one. I'm going to try to put it on here. I'm going to try to put both of them if I can. Let's see. All right, well, this is looking pretty good on answers. I've got every one of them. Let's see if I can put in another one without. What happens if it. All right, let me put in the other ones. Let's see. All right. 8. I'll try to put 2 in here at one time. All right. I think you're going to see 2 of them up there now. What happened to it? Can y'all see it? No, I'm not going to spend any more time on it. I thought I could do 2. I don't see what if before it was like hiding it. I could see it, see the poll once I ran it. All right. Well, let's just go ahead and. Did anybody get an answer on number 8?
Yeah.
All right. Well, I'm going to tell you what I'm going to do. I'm going to substitute, put all this over there rather than type it out.
I got 34 for 8.
All right, well, let's see. All right, so number 7, I'll just work that one out quick too.
26.
Yeah, it's 26. Good, y'all all got that one, I saw. So it's 4 times 8 minus 2 times 3. So that ends up being 32 minus 6 is equal to 26. Good. All right, on this one, you just got to watch out because some of these numbers are fractions. But this is 56. I'm sorry, 5 times 6. And then that's a division. That is a plus, isn't it? Or is it a
Yes.
division? Yeah. That's why I said is. We won't be using that little symbol. I don't know why they even always put it in here. It's just too hard to tell the difference. So do the multiplication and then we'll add. So 5 times 6 is 30. 8 times 1/2 is 4. In other words, it's 8 over 1. Two goes into 8 4 times and into itself once. So that's 4. All right. And then over here, this is the one that's going to be a little bit aggravating because it's got some fractions in it. But we know about the rules for fractions. If you write your whole numbers like this, it'll make it all the much easier to deal with. And then that's 3. M was 3. All right, so if you handle it like this, major issue taken away because 8 over 8 is just 8 over 1, so the 4 goes into here twice. And then all of your denominators now are 1. So it's 3 times 2 is 6.
6 times 6, 36.
Yeah, it's going to be 36. And that is 12, correct? All right, any questions about those?
No.
All right, so, later on when we start jumping into equations, and we'll work with equations pretty much the rest of the semester, when you are asked to evaluate, you're going to have to plug in, X is equal to this and that, and that's what evaluation means. All right, so and then translations. All right, so generally when you're translating words, you're looking for key words. You might be see 3 times something or twice something. Sometimes you might even say the word thrice, which means 3 times. But after that, there aren't really many other words. You're just going to be 4 times or 5 times. Well, when you see that, that just means times. Twice, 3 times, thrice. That's all multiplication. If I were to say, I wish I had 3 times as much money as I have now, well, you multiply however much you have now by 3. So twice the sum of 5. So 2 times. Now it's saying the sum. So that means we're going to open up a parentheses. If it had said twice 5, then we would have 2 times 5 there. But it says twice the sum of 5 and a number. Now the sum just means that we're going to take 5 and a number, put that inside of a parentheses, which forces us to do those first and then do the multiplication. Now we can't really do anything with it until we find out what x is equal to, but that's not the point of the exercise here. We're just simply writing what we see in words into symbols. So twice the sum of 5 and a number. Whenever you see something like a number or an unknown something, then that's going to be your variable. So 2 times x plus 5. All right. Let me put these over on the.
Mommy?
All right, I'm gonna put these over onto our little board. All right, so let's just, all right, so remember, basically, you're looking for words that denote multiplication, addition, subtraction, division, and then you're looking for something that denotes a variable. Usually that's going to be a number, is usually the way it's written. So a number increased by 7, how would we write that? A number increased by 7.
X plus 7?
Yeah, that's all there is to it. If it said decrease, then you would have put a negative sign there, x minus 7. A number increased by 7. So if x were 20, then our expression would be 27 because it's whatever value of x is plus 7. 8 less. What does that mean? 8 less. Less. What does less mean?
Minus.
Okay. I think something's missing here. It should be equals there. Equals 30. I think. You know what? I think this is not even part of the problem, that 30 thing. I think that's just some numbers. So 8 less than a number. Now remember, addition, it doesn't matter which goes first or second. But with subtraction, if you say 8 less than a number, we got to reverse that order. Okay, see why that happens? If we'd said x plus 7 or 7 plus x, it really doesn't matter. But when we're talking about subtraction, and this also works for division as well, the second number is the one we're going to be subtracting. So 8 less than a number, the order implied there goes one way, but there's only one way to represent it, by taking 8 from whatever x is. So again, if x were 20, then the expression would be worth 12 because it's 20 minus 8. 20 take away 8. So even the order given is, we have to flip it around sometimes when we're talking about those two things, a subtraction and division. twice the sum, okay? So since we got that word sum in there, that means then we're going to have some parentheses. And we're going to twice that sum. And then what's going to go in the parentheses is this little part. All right? A number, actually, let me back up. This is the parentheses. This is going to mean equals. All right, so we're going to put our parentheses in here. Twice the sum of a number and 4. So that's like what we said up here, and it was like the example. X plus 4, the sum. And when you see that word, the sum, generally that means you're going to have to use parentheses when you if it says something about multiplying the sum. Is always equals, and then twice the number. So twice the sum of a number and 4 is twice the number. And that right there is we're going to find out coming soon. That's something that we could solve and figure out right there. That's actually an equation. We could find out what x is equal to. The product of twice a number, well, we don't know what that number is. Twice the product, so the product means multiply. Twice a number and 7, product. So that's just saying 7 times twice a number is 12. And then we could simplify that down because in the case up here, there's nothing much we can do until we know what x is. But here we've got this right here we could take out and we can write 14x is equal to 12. Oh, you know what? I messed up. What did I mess up at? Y'all figure out. Look, I'm trying to rush this and I just realized I fell for the same thing that I didn't want you to fall for up there. Twice the product. So that means hold on a second. I think I hit it right. Let's back up. Yeah, I hit it right. The product of twice a number. So there's twice a number times 7 is 12. So you could simplify that one down to 14x is equal to 12. That was right. All right, any questions about anything? I mean, that's pretty much all there is to chapter 1, but we got some time here so we can back up and look at anything. Let's see what we got. Remember we had 1.2 was the one where it's just asking about definitions mainly, about the number structure. 1.3 is fairly simple. It's just a matter of taking fractions and whittling them down till they're simplified, meaning that they're simplified when there's no longer a common factor. Okay. And so there's really two ways to do it. I use both of these because if you take numbers and factor them into their prime factors, it's a lot easier to cross them out and you don't have to guess about it. With the division method, sometimes if you don't get the greatest common factor right off, you can come back and do it again. And that's most of the time I'll just do them by the division method. And then if I get stuck on something, I said, well, I can't see how this whittles down, then I would go back up and factor into common factors, and then you can just take them out. And what's left over, you just multiply it back. Let's see. And then we looked at the addition and subtraction. I'll just review this again because I'm not sure I mentioned this to you folks that. But this is the gist of it. Multiplying, dividing, sign number. Well, no, that was addition and subtraction. That's not addition and subtraction. All right. Let me write in here. All right. All right. So in the first case, so this will be, I'll just put A. So if they're both positive, you just add them up. And if they're both negative, you just add them up, but you got to tack on the negative sign. And then the other case is if they're different, all right. So if the numbers have different signs, then we take the difference and take the sign of the larger number, and I put ABS for absolute value because it's technically, it's not the larger number, it's the one with the larger absolute value. So if it was negative 20 and 10, then they're both different signs. So you would subtract or take the difference, that's what subtract is, and then take the negative sign from the 20, negative 20, because it's larger, and that's a air quote larger. Technically, it's not larger, but it has a larger absolute value. So that was what this was all about here. Okay. Any questions about that? And then this right here, example 3, that's what I was showing you with that little thermometer. I was trying to show you why that happens. When you subtract across the axis, the 0 axis, then you end up adding because you're going in the opposite direction. Where did I put that little thing at? See, that's what I was talking about here. If you subtract on the same side, like 20 minus 40 is a difference of 10. But if you go from 20 positive down to negative 10, when you subtract 20 minus a minus 10, then you're adding 10 because you're subtracting the opposite sign. All right. So that's why we end up adding when we go across, when we subtract a negative. All right. Any questions from these things? All right. And then there was the division, multiplying and division. The real lesson here was for multiplication, you're dealing with same sign. In other words, when you multiply or divide, if they have the same sign, then the product or the quotient is positive. If they're different signs and matched signs, then the product or the quotient is negative. Now, for division, you got to remember this, because as I had said is, generally speaking, fractions mean division. So when we divide one number by another, then what we do is we multiply by the reciprocal. In other words, 4/7 divided by 2/3 is 4/7 times, notice the flipped, that's what's called the reciprocal, 3/2. And then you can do the same thing that we did up here, which was taking out any common factors top to bottom. Because remember, when you're multiplying them, then all those things are fair game to be taking out common factors. All right. Any questions from this section? Y'all hearing me all right, aren't you?
Yeah.
Okay, good.
Yeah.
All right. So none of those people ever showed up that I mentioned? Let's see. Let me do it one more time. Victoria Aldrat, Joni Davis, Rowan Issa, Niara Morris, Hector Rivera, or Jade Williams. None of those ever showed up, right? Okay. Let's see. What was the next thing? Oh, we already looked at that. Oh, they put those two together. Okay, that's why. All right. And then this is what I mentioned about the adding and subtracting. And this is, again, that's what this whole thing is about. If they're the same sign, in other words, both positive or both negative, then the output is positive. If the signs are different, then the output is negative. Now, just remember, you're always doing two at a time, so this always works. You can tell if you've got 5 numbers being multiplied and you can count the negative signs, then you know it's going to be negative, because it's an odd number of negatives. But it works like this as well, but because you're always only looking at 2. Let's see. And then, like I said, this is what I just mentioned about that. The 2 negative signs or 2 positive, then it's always positive. All right, and then this was the last thing that we looked at. Any questions about any of that? Always, as a general rule, if we got time, I'm going to start on a little bit on the next material. And the reason being is because if something happens that I have to miss, which is not that often. I mean, last semester I missed a day. And then we had also 2 or 3 days for hurricane days. So you never can tell what's going to happen. And we're obviously not going to have any more hurricane days for a while. I guess that's not, never say never, but what I'm going to do is just let's look at 2.1. And then that way we won't have so much to go over if something happens. So which means that we always got time for questions. So bring them if you don't have them now. Don't feel bad about asking them. You can shoot them to me privately or whatever. I'm just kind of trying to get used to the chat on here. It's just, I can't always see if I got somebody with a chat answer, but all right. Oops, I'm in the wrong spot. I'm supposed to be at home. Course materials is where you go to your My Math Lab. And as I have, if you didn't get this, here in home, that's where the syllabus and the course calendar is. Those are important. There's some other things in there that we briefly went over. You're going to have to make sure you can use the Proctor You Record thing. That was the first thing we talked about, study skill tips. If that, I didn't spend too much time on that. So now we're in chapter 2. And as I said, for each of these, generally there's a PowerPoint that's been converted to a PDF, and also the worksheet, which is what we usually look at in class. If you want the actual PowerPoints, then you can get it through the My Math Lab multimedia section. All right, so chapter 2 is just where we kind of formally get talking about algebra, okay? All right, so that means that we're now like dealing with variables. All right, and sometimes it's a little bit tough to understand, but we got to figure out what like terms are. Like terms means that the variable part looks the same. All right. Let's see if I can find a good little picture to show you. That's not the right stuff. All right. Here looks like a good one. All right. So what like terms means is that they have the same variable part. So 4x squared and 5x squared, we're not worried about the number. We're only worried about the variable part and whether it's alike. Because what it amounts to, it's sort of like the same idea with those fractions that have different denominators. I'm sorry, that are not alike. In other words, they don't have the same denominator. So in other words, you can't really add them and subtract them until you do that, take care of that. But anything that has an x squared is like. So all of these ones in the green are alike. And so what we essentially do to combine like terms is just add up the 4, the 5, and this is an implied 1. So that would be 10x squared. The blue ones are the xy's, and we can look, these are all positive here. Again, so 3 and 7 is 10. 10 plus 10 is 20 xy. These two right here are both negative, but they're both the like terms, 14x negative, 14x negative. So 14 and 14 is 28, like term of negative, like sign of negative, so it means negative 28x. All right. So on this one, where you got 5x and 6x, both like terms. So 5 and 6 is 11x, and then you write that part just once. Number 2, 5x minus 7y minus 6x minus 4y. Now, they're not all in order, but we put the ones that are like 5x and negative 6x. We still use our number, our rules for whole numbers. 5x minus 6 or 5 minus 6 is minus 1, and then the common term of x. Negative 7 and negative 4, y, and these are just plain old y's. Negative 6 and negative 4 is negative 11y. Okay. So for this one, the simplification involves doing a little bit of multiplication first. We got to do a distribution first because we got a negative 2 in front of the parentheses. So we can't take those out until they're multiplied by the negative 2. So 12 minus 2 times 3x is negative 6x, mixed signs. Negative 2 times 8 is negative 16. Now we can put together the like terms. Negative 6 and negative 1x is negative 7x. And then 12 minus 16, or those are both whole numbers, so they're like. So that's negative 4. Negative 7x minus 4. All right, so look at these as we kind of head out and see how many of these you can get. And I'll take your questions about them when we get back on Wednesday. All right. See if I can put it in over here. Put it down here. So what happens on number 1? Are they alike? 4 and 7x, 4x and 7x? 4 and 7 is 11x. 15y minus 1y. 14y, right? These are alike. 12x minus 18x. Like terms. So we just look at the number now. 12 take away 18 is negative 6x. On this, we got the x's are here and the y's there. So 10x and negative 12x, 10 minus 12 is negative 2x. Negative 3y plus 4y. So take the difference, and that's just a plain old plus 1y. Generally, you won't ever see a 1 in front of a variable because it's just understood that that's just one of them. So this one takes a couple of steps. You got 8x because you got 2 times 4x, and 2 times minus 6 is minus 12, and then plus your 3x. Now, once this one has out of there, then we can put the like ones together. So it's 8 plus 3. All right, here, the minus 4 is multiplying the x. And you got to watch out. This is one of the biggest mistakes I've seen students make. A negative in front, it's multiplying both of these. So you got to take into account negative 4 times negative 5, which is positive 20. So now the only thing that are likes are the numbers. So that's negative 4x plus 32. All right. So remember kind of that we can look at the rest of these when we come back. If you got questions about anything, also let me know. I'll let you get out of here a little bit early today. And if you got any questions, stick around. I'll stay here for a little bit. All right.